cosmos, space, and time travel, medicine, robotics, science, and technology. Professor Michio Kaku, theoretical physicist, graduated from Harvard University summa cum laude and first in his physics class. Received his PhD in physics from the University of California at Berkeley. And now, a professor of physics at City University of New York for 30 years. His goal? To complete Einstein's dream of a theory of everything, to derive an equation, to summarize all the physical laws of the universe. The co-founder of string field theory, author of the international bestsellers Hyperspace, Visions, and Parallel Worlds, and voted as one of the 100 smartest people in New York, profiling the latest cutting-edge developments in science, which revolutionize our world and touch our lives. Now, Science Fantastic with Professor Michio Kaku.
This is Science Fantastic with Professor Michio Kaku. On Science Fantastic, we profile the amazing, jaw-dropping scientific discoveries which are revolutionizing our world and touching our lives. And in this hour, we're going to bring on one of the nation's leading science writers, Corey Powell, science editor at Eon Magazine, contributing editor at Discover, American Scientist, you name it, he's written for it. And his next book is coming out next year called Everything All at Once, written with Bill Nye, the science guy. And so once again, Corey Powell is going to talk to us today about space, outer space. What's out there in this great universe of ours? As you know, recently the Juno space mission sailed past Jupiter, a bullseye 500 million miles from the planet Earth, and we hope to find evidence of the origin of the solar system itself. Jupiter, the biggest planet in the solar system, dominates the entire solar system. Our Earth would not have been possible unless the planet Jupiter basically plowed the original solar system, cleaned it out like a vacuum cleaner, and here we are today, compliments of the planet Jupiter. Then we're going to talk about Mars. Is it really possible that one day we can set up a colony on Mars like in The Martian? Or, for that matter, what about terraforming Mars? This is, of course, something that may take centuries, but what about the possibility that one day we may actually create a Garden of Eden on the red planet? And you probably heard that Stephen Hawking, my colleague, has come out with an interesting plan to send the first starship, not just an interplanetary probe, but a first starship to the nearby stars. And he hopes to do it with a starship the size of a postage stamp. That's right. You can forget about the Enterprise. It's simply too expensive to send the Enterprise to the nearby stars. But having a computer, a supercomputer the size of a postage stamp, give us all the information about the universe, that's something that is totally doable. And what about extrasolar planets out there? You know that the Kepler satellite has identified roughly 2,000 extrasolar planets. Well, these and other developments, we're going to be talking with our special guest today, Corey Powell, science editor at Eon Magazine. And also go to my website, mkaku.org, mkaku.org. And you can always give us a call, and you could be on Science Fantastic by calling 866-323-2129. So once again, go to my website, mkaku.org, mkaku.org. We have over 3 million people following on Facebook. And after the break, we're going to talk about the universe with Corey Powell, science editor at Eon Magazine.
You're listening to Science Fantastic with Professor Michio Kaku.
Welcome back to Science Fantastic with Professor Michio Kaku. In this hour on Science Fantastic, we're going to bring on our special guest today, and we're going to leap into outer space with Corey Powell. Corey Powell is a science editor at Eon Magazine. a contributing editor at Discover and American Scientist. In fact, he was 15 years on staff at Discover, 5 years as an editor-in-chief of Discover magazine, and he's coming out with his third book. His third book with Bill Nye the Science Guy, called Everything All at Once, which is going to be published next year in May of 2017. So, Corey, once again, thank you so much for being on Science Fantastic.
Oh, what a fun place to be. I'm very glad to be here.
Okay. Well, the first question we ask all our guests is, how did you, as a youth, first get interested in science?
Well, I think there was something in my blood or something in my DNA that really from a very young age, I liked classifying things in the world. I liked understanding how things work. Actually, I was very interested in plants when I was a little kid. All the different, you plant different seeds, and a slightly different type of seed produces a totally different kind of plant or flower, and that seemed really amazing to me. And then in second grade, we did a science project. They had a little, Earth and space unit in second grade, and each kid got assigned a planet, and I got assigned the planet Neptune. And I remember thinking, what a ripoff! I don't get Mars where there'd be aliens. I don't get Saturn where there's rings. I get Neptune. Who's interested in Neptune? And so I went home and I read. We had one of those golden books. I don't know if your listeners remember. This was back in the days before the internet. There was a very small pool of things for kids to look at, and these golden books were like little primers about how the world works. So I looked up Neptune. I was reading about Neptune. I thought, oh, actually, Neptune's actually pretty interesting. Neptune's kind of cool. There's like a lot of stuff we don't know about it, and stuff we do know about it is kind of interesting. And it's like a little switch went off in my head. It was the moment when I realized that even the things that I didn't know about, that seemed kind of boring about space, had all kinds of cool mysteries to them and all kinds of amazing possibilities. And I just kind of got hooked. I got a telescope. My parents got me a subscription to Astronomy Magazine, which was a brand new magazine at the time. And I just I never looked back. But then, when I got to really at the college level and started considering whether I wanted an academic science career, I discovered that in fact, I was not that well suited to scientific research. I loved the discovery process. I love the process of scientific storytelling. I turned out not to have the kind of patience and intellectual depth that some people like you perhaps have to really stick with the research side. But I discovered that I was actually quite good at kind of communicating the scientific discoveries and kind of acting as a conduit between the research community and the larger world. And that's how I ended up in the magazine world. And I've been there pretty much my whole adult life. So I get to be a fellow traveler with a scientist, and occasionally I've in different ways I've participated in some different scientific projects. But it's been a lifelong passion, and it's been a very, very rewarding journey for me.
Okay, and tell us a little bit about Eon Magazine, because you're the science editor there, and also a few things about your work with Discover Magazine as well.
Right. So I've sort of over the years I've made a bit of a kind of a hopscotch through the science journalism world. I worked at Physics Today, which is a magazine really kind of like communicating about physics to physicists. It's very much a kind of a fairly insider perspective. I worked at Scientific American, which is a bit broader and kind of reaching out to educated people who are not necessarily scientists. Then many years at Discover, which is broader still in trying to bring science to the masses. And my latest job is it's an interesting new experiment. So Aeon is a completely digital magazine and quite young. It's just been around since 2012. And it is really, it's kind of it's sort of a work of intellectual passion. It was two academics and publishers in Australia who pulled together some family money and started this magazine basically, to write about, to publish the kinds of articles in science and politics and culture that they themselves wanted to read. And again, like many of my favorite publications, it's really about bridging worlds, about sort of taking these very deep perspectives from academia that don't always make it out into the popular world and delivering it to a wider audience, and trying to achieve a somewhat, I feel like we're in a strangely split world right now where people have access to deeper ideas than they've ever had before, and they also have access to more crazy and superficial information than they've ever had before. So I feel like we're always trying to strike a better balance to make sure that there some of the incredible richness of what's happening in academia, of what's happening in scientific research, to make sure that people know that and they can appreciate it and that they can enlarge their lives with it.
Okay, well, let's just move right on. Okay. Let's just move right into, for example, the Juno mission, which grabbed a lot of headlines recently. Tell us a little bit about the importance of the Juno mission and the planet Jupiter.
Well, the two go hand in hand. I mean, what's really Jupiter is the largest planet, and it's not just it's the largest planet. Jupiter is kind of the keystone to understanding how the solar system formed and evolved very, very early on. Jupiter's gravity was really kind of influencing the whole evolution of the early solar system. And there's a lot of evidence now that when the planets were forming, they didn't just kind of like form in the places where they are now. There was a lot of moving around. Like the early solar system was a very kind of erratic and chaotic place. And Jupiter, as the biggest planet, was kind of the conductor of this whole kind of chaotic symphony. So if you can understand how Jupiter formed, you can understand basically how everything was moving around, how water got to the Earth, how Pluto and those other little things got flung out to the outer part of the solar system. Why we have 8 big planets in our solar system and not 2 or 20. There's just some basic questions we don't understand about where we came from and whether there are other solar systems that could support life around other stars. So, so understanding Jupiter is kind of like the key to understanding a lot of that, and that is really the focal point of what Juno is about.
Now, Jupiter is the 800-pound gorilla in our solar system, right? Yeah. It outweighs all the other planets put together. And in some sense, it's also like a cosmic vacuum cleaner that vacuums out all the comets, meteors, debris. So isn't it true that if it wasn't for Jupiter, life would be impossible on the Earth, that we'd be pelted with asteroids and comets, and there'd be a gigantic crater where we are now in New York City? So we owe it all to Jupiter, right, to clean out the solar system?
Right. This is one of the really interesting questions, which is, what exactly did Jupiter do? Jupiter is both a vacuum cleaner and a snowplow. Jupiter swept up a lot of material, but also rearranged a lot of the flow of where things went. And one of the ideas is that as Jupiter was moving back and forth in its orbit, that it actually shoved a lot of kind of icy comets and asteroids into the inner solar system. Those are the things that landed on the very, very early Earth, and that's where our oceans came from. So there's there may be in fact 2 ways that we have a debt to Jupiter. One is that it helped us early on with water and organic chemicals and things that made life possible, and the other is that later on, as you say, it acted as this vacuum cleaner and kind of protected us from getting bombarded. So again, the question is, if you have another planetary system around another star and it doesn't have a Jupiter, does that mean that those planets there are all out of luck, or are there other ways that you can make an Earth? Is this the only way to do it?
Now, Jupiter is also quite radioactive with lots of radio disturbances as you approach it. And many people are startled to find that a lot of the static we get here on the planet Earth actually comes from Jupiter. So the next time you get snow on your TV, static on your AM radio, you can blame it on the planet Jupiter. But that also makes it rather dangerous to get there, right?
Right. Well, it makes it dangerous if you want to get anywhere close, and that's the real challenge with this Juno mission, because Juno is going to get extremely close to Jupiter. Juno, its closest, is going to get less than 5,000 miles above the cloud tops. So it's like Juno will be closer to the surface of Jupiter than, say, Beijing is to New York. So it can be right there in the thick of it. And that's one of the reasons why this mission is not going to be a terribly long-lasting mission. It's going to last maybe 18 months because the radiation is very, very quickly going to wear down all the electronics and all the systems on the spacecraft. It's actually built with a titanium vault. The electronics are encased in a box of about a quarter-inch thick titanium, just because without that, the probe will be fried instantly.
Now, also, after the mission is completed, as you mentioned, the probe is going to be sent into Jupiter to die. Now, the previous mission, the Galileo mission, was also sent into Jupiter to die. But some people said, well, it's not sterilized. So even though, of course, most of the germs are going to die on the way to Jupiter, is it such a good idea to send probes crashing into other extraterrestrial bodies that have our germs on them? What are your thoughts?
Well, what happens is you have to make trade-offs of, what you want to learn versus how careful do you want to be about not disturbing things. I think the likelihood that there is life on Jupiter or in Jupiter, based on everything we know, the likelihood of that is pretty low. And when you're talking about crashing into Jupiter, you're talking about basically turning this irradiated spacecraft into a flaming meteor. I think the risks you're talking about are pretty low. I mean, that said, the reason that we're crashing it into Jupiter instead of just kind of leaving it there in orbit is that if it stays in orbit, there's a chance that eventually it would crash into the moon Europa. And moon Europa is a place where we do think there's a good chance of life. And you definitely do not want to be crashing into a moon that's it's icy, has an ocean. It's a place where if there are any Earth germs that manage to survive on that spacecraft, Europa is a much more worrisome place to contaminate. So at some point you make your choices of as soon as you go out and explore, there's some risk of contamination. You just want to do the very best that you can.
And speaking about the Europa mission, right? Wasn't it the Galileo mission that first began to seriously focus interest on whether or not life might exist on an icy moon of Jupiter? So explain to us, how is it possible you could have a liquid ocean underneath the ice cover of a moon that is millions, billions of miles from the stars?
This has certainly been one of the most exciting discoveries in planetary science over the past 20 years or so. Starting with Galileo in the late 90s, realizing that water is not a scarce thing in the universe. Once you get out to Jupiter and beyond, almost all the moons of the giant planets contain a lot of water. But the thinking was always, these are little worlds that are frozen solid. There's nothing interesting or dynamic about them. But it turns out they have gravitational interactions with each other. They're always kind of pushing and pulling at each other. And what happens is, that it creates friction. It's like if you just kind of like squeeze a piece of silly putty or something and it warms up. These moons are expanding and contracting. They're getting what's called tidal heating. They get warmed up inside. And what we're realizing now is that a lot of these moons, the small icy bodies, have oceans inside. Europa has a big ocean inside. Saturn's moon Enceladus has a giant ocean inside. There's now actually pretty good evidence that Pluto has an ocean inside. And that means, if you're looking for liquid water as a place to look for life, we used to always think, you're looking for the Earth, another Earth. You're looking for, a planet that has continents and oceans and blue skies and it looks like home. But in fact, what we're realizing is most of the liquid water in the solar system, and probably most liquid water in the universe.
Okay, Corey,
Not
we have to take a short commercial break, but after the break, we're going to talk about Mars and the exploration of the red planet, and one day will we go to the stars. Once again, our special guest today is Corey Powell, science editor at Eon Magazine, contributing editor at Discover, an American Scientist, and his next book is coming out next year called Everything All at Once. So, and you can also give us a call and make a question or make a comment. So stay tuned for the next segment of Science Fantastic.
You're listening to Science Fantastic with Professor Michio Kaku.
Welcome back to Science Fantastic with Professor Michio Kaku. With us in this hour is Corey Powell, science editor at Eon Magazine, contributing editor at Discover, an American Scientist magazine. And his next book is coming out next year called Everything All at Once, written with Bill Nye, the science guy. And once again, this is Science Fantastic with Professor Michio Kaku. If you want to get on the air, give us a call. The hotline number is 866-323-2129. You'll get a recording. Just leave your name, the call letters of the radio station you're listening to, and the city you're calling from. And perhaps your thoughts will be heard on national radio. Also, check out my website. It's mkaku.org, mkaku.org. Check out my Facebook site. We're up to now 3 million fans on Facebook. On Twitter, we have 500,000 people on Twitter. And if you go to my website, you'll see what cities I'll be speaking in, talking about my latest book, The Future of the Mind, my third New York Times bestseller. Future of the Mind actually hit #1 on the New York Times bestseller list. Well, Corey, where we last left off, we were talking about the exploration of the solar system. And now let's bring it closer to home. Let's talk about Mars. First of all, the question that everyone wants to know is, have we found any evidence whatsoever of any life on the red planet? Yes or no?
This is one of those really annoying times when I'm going to have to say maybe. By coincidence, today is the 40th anniversary of the Viking 1 landing, the first landing on Mars, and the only serious experiment that humans have done to look for life on Mars. And the results of those experiments were very ambiguous. I mean, there was no clear evidence of life, but there were some very strange things. It turned out that we didn't really understand a whole lot about really how you look for life. We didn't understand a whole lot about the chemical complexities of trying to do a science experiment like that on another planet, basically by remote control. So, this is why, you hear these endless headlines of like, oh, NASA's found more water on Mars. They found water here. Life might be there. We have, even after 40 years of exploration and all this different type of research, we still have really very ambiguous information. I think it's pretty clear that if there is life on Mars today, it's probably buried deep underground where there still are traces of water, where there's some warmth, where you're protected from radiation. And you're probably, if the only way you're going to find it is by sending a mission that can drill down deep and it can do very sophisticated research to look for it. So, I mean, the frustrating answer is we're not going to have an absolute answer for a long time, and probably what's going to happen is we're going to look more and more places and not see anything. But it's very hard to prove a negative. It's very hard to prove that there's not life on Mars.
Okay, well, NASA has said that sometime in the 2030s, we don't know for sure, but sometime in the 2030s, we may send a manned mission to the red planet. So first question for you is, did you see the movie The Martian with Matt Damon? And what are your thoughts?
What am I, made of stone? Of course I did.
And what are your thoughts? How realistic is it? And how dangerous is it to go to the red planet? What are your thoughts?
Well, look, going there is completely realistic in terms of technology. If we wanted to send, if you gave NASA, let's say, $200 billion, and told them, to finish developing all these technologies and, finish developing the space launch system, this giant rocket that NASA is working on. There's no question in my mind we could send humans to Mars, and we could probably do it on a 20-year time scale. The problem is that right now that money doesn't exist. Right now, NASA's whole program of sending humans to Mars is pretty much fiction. It's real in the sense that there are engineers who have a pretty good idea of how to do it, and if it were funded, we probably could do it. But it's fiction in the sense that there's no economic backing and there's no political support for it. So I think in all likelihood, somebody like Elon Musk, who can do it using his own resources and do it because he wants to do it, is actually much more likely to be sending humans to Mars than NASA is. Not because they don't have the technology, but because they don't have the will, they don't have the political support.
Okay, and speaking about Elon Musk, the billionaire behind PayPal, behind Tesla Motors, and behind SpaceX, Elon Musk has been making headlines. First of all, he said that perhaps one day, in order to make a paradise out of Mars, we should nuke the ice caps, put hydrogen bombs there, so I'll ask you about that. And the other question is, well, he said that if NASA won't do it, he'll do it, that he'll send a probe to Mars. So let's take a short commercial break, and after the break, we're going to talk about the exploration, not just of Mars, but the stars. Stephen Hawking, my colleague, has come out with an ingenious device to send the first starship to the nearest stars, but it does not look like the Enterprise. So let's take a short commercial break. Once again, if you want to get on Science Fantastic, give us a call. The hotline number is 866-323-2129. All we ask is that you leave your name, call letters of the radio station, and the city you're calling from, and perhaps you can get on over 100 radio stations that carry Science Fantastic.
This is Science Fantastic. Professor Michio Kaku.
Welcome back to Science Fantastic with Professor Michio Kaku. Once again, in this hour, we have with us Corey Powell, science editor at Eon Magazine, contributing editor at Discover and American Scientist Magazine. And his next book is coming out next year called Everything All at Once. Well, Corey, where we last left off, we were talking about Mars. So, well, what are your thoughts? Of course, science fiction writers talk about one day terraforming Mars, that is, making a Garden of Eden out of the red planet. We even had on our radio waves Robert Zubrin, the founder of the Mars Society, who even has a plan to create a Garden of Eden on the red planet. But what are your thoughts? You think that Mars is ripe for colonization, or do we have to wait a few generations?
Let me break that into two questions. Mars is ripe for colonization? Absolutely, no question. Mars is ripe for terraforming? Not anything close to where we are right now. I mean, I think terraforming is a really fun idea to think about. But let's think about that. We're doing terraforming on Earth right now. We're emitting greenhouse gases. We're doing things that are altering the global climate. Just trying to take control of that process and make sure that it doesn't run out of hand. We're not doing a very good job of that with basically every nation on Earth having a very strong interest in making that work. I think we're very, very far away from actually understanding how you would terraform Mars. But let me say, thinking about the idea of how to do it is actually incredibly important because you learn a lot in the process. And I do think, look, there are caves on Mars where astronauts would have a lot of protection. There are these interesting apparent water flows on the sides of certain craters that indicate that there actually is some kind of water that's available at the surface of Mars. I mean, there are some really interesting things that human astronauts could do to establish a colony there, to really understand whether or not there's life on Mars, to understand what it is to explore the solar system and to establish a human presence on other planets. You would need to do a lot of that before you can talk about terraforming. But I love that people like Elon Musk are thinking not about what we'll be doing in 5 or 10 years, but what we could be doing in 50 or 100 years. Now, that time scale, sure. I think there's going to be a vigorous discussion about whether the role of humans is to are we the interplanetary park service where we're preserving other planets, or are we colonialists who are going and setting up human presence on other worlds? I think there's going to be a real debate about that.
Okay, and let's move even further into outer space to the stars. Well, if the Saturn rocket were to go to Alpha Centauri, the nearest star, it would take 70,000 years. So let's take a short commercial break. And after the break, let's talk about an idea circulated by Stephen Hawking and others to send the first starship to the stars. So let's take a short commercial break. Once again, you are listening to Science Fantastic with Professor Michio Kaku. Give us a call. The hotline number is 866-323-2129. All we ask is that you leave your name, call letters of the radio station, and the city you're calling from. And perhaps your thoughts will be heard on national radio. So write this number down, 866-323-2129. Yeah, you're not going to get a busy signal. You get a recording. Simply leave your name, call letters of the radio station, and the city you're calling from, and ask your question on national radio.
This is Science Fantastic. Michio Kaku.
Once again, you are listening to Science Fantastic with Professor Michio Kaku. Once again, our special guest today is Corey Powell, science editor at Eon Magazine. Well, Corey, as you know, my colleague Stephen Hawking made headlines once again by saying that we should go to the stars, not just out to Pluto, but way out there to the stars using a starship, not the size of the Enterprise, but a starship the size of a postage stamp. So could you elaborate?
First of all, let me say, I think this is actually one of the most exciting ideas in space exploration right now. So I'm glad to have a chance to talk about it. I mean, the idea is, the entire history of space exploration, really, the entire history of rocketry going back 1,000 years to the early rockets in China, it's all been based on this idea that basically, you light some chemicals, the flame goes out a little nozzle, and it makes you move. It's a great concept that's very limited and very primitive in a lot of ways. The idea that Stephen Hawking is promoting is a thing called a laser light sail. It's a totally different concept where you attach, as you say, a really, really small probe to a very, very large, very lightweight reflective sail, and you blast it with a laser beam. And the laser beam is actually, it gives energy, it gives momentum to the sail. You can accelerate this thing very, very powerfully, and it has no fuel on board. Basically, you have a laser that's on the ground, or maybe it's in orbit or on the moon, but the laser stands still. You're just zapping the spacecraft. The spacecraft, you can accelerate it to, in principle, 5, 10, even 20% the speed of light, to 1,000 times faster than anything we've ever built before.
Okay, now let's talk about, some of the downsides of the idea. In order to propel it, you need a laser bank capable of generating 100 gigawatts of power. That's 100 nuclear power plants. That's a lot of nuclear power plants aimed very precisely at a postage stamp. So what are your thoughts about whether or not one day we can assemble 100 nuclear power plants to energize this starship?
Short answer, yes. If you're doing pulsed power, you don't necessarily need 100. I think you can probably get away with 5 or 10 and some energy storage, and you do very intense energy pulses. If you imagine doing this on the moon, the idea of building, let's say, 5 nuclear reactors and a storage system and a solar array on the moon, I'd say ambitious. It's huge, but it's not outside the realm of what we know how to do technologically. Again, how to make the laser sail. You would need a breakthrough in in precision pointing. You'd need a huge laser array. You would need a new kind of communication system to get signals back from your little probe. All these things would require significant technology breakthroughs, but they're all, again, based on known principles. We're not talking about warp drive. We're not talking about dilithium crystals. We're not talking about anything kind of make-believe. We're talking about an incredible but realistic extrapolation of things that we know. To my mind, if you were talking about where to put a giant investment to really do it, and it's a human technology breakthrough, this is one of the great places to do it.
And with the advances in computer technology, you could probably put an entire observatory and science laboratory on the postage stamp so that as it goes to the nearby stars, it'll take detailed photographs and perhaps land on one of these planets and send signals back, right?
Well, so again, part of what's really interesting about this concept, again, because there's no rocket involved. The spacecraft is not, it's not sitting on any kind of propulsion system. The spacecraft is really just this little, maybe iPod size or even chip size thing attached to a sail. So the spacecraft could actually be built very cheaply. You could mass produce them. So instead of sending one probe to Alpha Centauri, what if you send 1,000 or 10,000 or 100,000? I mean, as crazy as that sounds, almost all the money that you'd be spending is building the laser. The probe itself would cost almost nothing. So you would be sending out giant clouds of spacecraft in different directions, and one of them fails, it doesn't matter. If one of them misses its target, it doesn't matter. It's a completely different way of thinking about space exploration. And you know what? And if it turns out that it doesn't get you to another star, the same technology would be incredibly powerful just for moving around through our solar system, for building, a space transportation network. So it's one of these things where, as far as we can take, every step along the way of the technology would be useful and would be a breakthrough.
Okay, and let's also move forward and talk about what we may find with a starship that could then begin to reach the nearby stars. Recently, with the Kepler satellite and other sources of astronomical instruments, we've been able to detect all sorts of bizarre planets circulating around other star systems, right? Triple star systems. Can you imagine 3 stars in a system with planets going around it? Originally, didn't people think that was beyond natural law?
Let me say, almost everything that we've discovered over the past 20 years of looking at planets around other stars, almost every step along the way, what we've seen is something that the theorists said was impossible. I think this has been a very humbling experience because you think about how does a star make a planet? It's basically, you just have gas, dust, and gravity. It's just the stuff swirling around, and then some of it falls into the star, some of it makes planets. In theory, the physics of that should be pretty simple. But then the reality of, what does a planet look like? Where can planets be? Which planets could support life? Almost every idea that we had about that, almost every answer we had about that turned out to be wrong. When you actually go and look, there are Jupiter-sized planets orbiting closer stars. There's stars around planets around triple stars. The universe is full of surprises.
Okay, Corey, unfortunately, our time is up. Once again, our special guest today has been Corey Powell, science editor at Eon Magazine, also contributing editor at Discover, American Scientist, and watch for his latest book coming out next year. It's called Everything All at Once, written with Bill Nye, the Science Guy. So, Corey, once again, thank you so much for being on Science Fantastic.
Oh, thank you so much. The time flies when we're talking about these things.
Right. Okay, and once again, you are listening to Science Fantastic with Professor Michio Kaku. If you want to get on the airwaves, is 866-323-2129. And perhaps you can get on over 100 radio stations that carry Science Fantastic.
You're listening to Science Fantastic with Professor Michio Kaku. Black holes, the cosmos, space, and time travel, medicine, robotics, science, and technology. Professor Michio Kaku, theoretical physicist, graduated from Harvard University summa cum laude and first in his physics class. Received his PhD in physics from the University of California at Berkeley. And now, a professor of physics at City University of New York for 30 years. His goal? To complete Einstein's dream of a theory of everything, to derive an equation, to summarize all the physical laws of the universe. The co-founder of string field theory, author of the international bestsellers Hyperspace, Visions, and Parallel Worlds, and voted as one of the 100 smartest people in New York, profiling the latest cutting-edge developments in science, which revolutionize our world and touch our lives. Now, Science Fantastic with Professor Michio Kaku.
This is Science Fantastic with Professor Michio Kaku. On Science Fantastic, we profile the amazing, jaw-dropping scientific discoveries which are revolutionizing our world and touching our lives. And in this hour, once again, we're going to throw the lines open because it's open mic on Science Fantastic. Why should science be confined to scientists? Why do we have all the fun? Why not you? Why can't you get to the telephones and give us a call and you can participate in the March of Science? Give us a call. The hotline number is 866-323-2129. The phone lines are open. You're not going to get a busy signal. You'll get a recording. It'll ask you for your name, call letters of your radio station you're listening to, and the city you're calling from. And perhaps your thoughts will be heard on over 100 radio stations that carry Science Fantastic. That's right. That's all you have to do is pick up the phone, call 866-323-2129, and you can share your thoughts on national radio. And let's say you're at the dinner table and your kids ask you a science question from homework that leaves you stumped. I mean, what are you going to do? Act dumb? No. You're going to get to the phones and call 866-323-2129. And for that matter, why not put them on the phone? Why not have them get on over 100 radio stations that carry Science Fantastic? So once again, the lines are open. And also, you can always go to my website. It's mkaku.org, mkaku.org. On Facebook, we have over 3 million fans on Facebook. On Twitter, we have 500,000 people picking up my Twitter feeds. And why not find out what all the fun is about? Why should we scientists have all the fun? The fun of exploration, about exploring the universe, about understanding our genome, about understanding the origin of who we are. Why should we scientists have all the fun? Why not you? And just remember that no question is, quote, too dumb or silly to put on national radio. Just remember that some of the greatest breakthroughs in science were done by children who asked children's question. When a 16-year-old boy asked a question, can you outrace a light beam? That young boy, 10 years later, would change world history. That teenager was called Albert Einstein. And when he finally answered the question, can you outrace a light beam? He changed world history. Nothing has been the same ever since. Why do we have hydrogen bombs and atomic bombs? Why do the stars shine? How do we think the universe itself was created? All of that unleashed by a 16-year-old boy who asked himself a simple question. Can you outrace a light beam? Okay, once again, the lines are open. You can always give us a call at 866-323-2129. Okay, well, moving right along, let's take the first listener phone call.
Hey, this is Blake Steele from Chattanooga, Tennessee, calling from 102.3. I was just wondering, what exactly is radioactive material and...
Okay, well, we hear about radiation all the time, but the question is, what is radiation? Well, very briefly speaking, when you smash an atom apart, you break it apart, it's called an ion. But if you smash the nucleus at the very center of the atom apart, you get subatomic particles. And the fragments of atoms and subatomic particles are called radiation. Now, of course, there are many types of radiation because there are many constituents within the atom. The most common form of radiation is electromagnetic radiation. That is radio, television, visible light. All of that travels at the speed of light because that's what light is. Light is a form of electromagnetic radiation. X-rays, for example, are ionizing radiation, which can be potentially quite dangerous and give you cancer because it, in turn, can rip apart atoms. On the other hand, radio is non-ionizing. It does not have enough electromagnetic energy to rip apart the atom, so it is not as dangerous as X-rays. So that's one form of radiation. Then we have subatomic particles, alpha rays, beta rays. They're much more dangerous in certain ways. And they're found, for example, in fallout. If you have an atomic bomb, it releases an enormous amount of X-rays and other kinds of radiation, but it also makes radioactive dirt. So the dirt created by the hydrogen bomb that is lofted into the sky eventually rains down on the planet Earth in the form of radioactive byproducts. That is, atoms that have been ripped apart, which in turn release beta rays, which are electrons, and alpha rays, which are the nucleus of helium. Those potentially could be dangerous. They cause ionizing radiation, which can cause mutations. And mutations in turn can alter the very structure of life. And so we have a situation here where, yes, indeed, radiation can be dangerous, but we also have ways of controlling radiation as well. We have ways in which we can measure it, and we have shielding to protect us against radiation. But of course, sometimes it just gets out of control. Take a look at Chernobyl. Take a look at 3 Mile Island. Take a look at Fukushima. There we had reactors which literally blew their lid, like at Chernobyl, releasing all sorts of radioactive debris that eventually wound up in people's dinner table and in people's backyard. And so, once again, radiation can be dangerous. It can harm you, but also radiation can cure diseases. For example, radiation treatments if you have cancer. And the sun itself releases radiation which makes life possible. Sunlight is a form of radiation as well. Okay, well, moving right along, let's take the next listener phone call.
Hi, my name's Charlotte, and I'm from Bradford, New Hampshire. I'm calling to ask if insurance companies and employers are not permitted to discriminate against people with certain genomes that have been identified on the basis of disabilities or what have you. Then why is it that when we talk about children who might potentially be identified in the womb as having certain disabilities, genetic defects or markers, why is it that doctors are permitted to discriminate against these children?
Well, you ask an extremely important and touchy question, and unfortunately the law is not clear on these questions. However, let's break it down into its components. First of all, it costs about $500 to $1,000 to have all your genes sequenced. Personalized gene sequencing allows you to basically get all the genes that make up your body. Now, some of these genes are broken. They're mutated. They don't function properly. For example, for Caucasian people, they have to worry about cystic fibrosis. If you're African American, you have to worry about sickle cell anemia. If you're Jewish, you have to worry about Tay-Sachs. Each of these is caused by a mutation within our genes. So far, so good, right? But now we have the law coming into the picture because, as you know, laws have been passed to try to protect us against the predatory practices of insurance companies that may want to kick you out, if you are predisposed to certain kinds of diseases. For example, Angelina Jolie, the movie star, made headlines recently when she had a double mastectomy because she was very likely very likely to have breast cancer. She had the genes for breast cancer. The doctors told her that she had a very good chance of breast cancer. It ran in her family. So she had to make a decision to have a double mastectomy. But now you ask an even more delicate question: what happens in the womb? Now, for good or bad, it's possible to detect the genes that make up fetuses before they're born. For example, in Brooklyn, in New York, there's even a group of Orthodox Jews that make it possible to have the genome of the fetuses analyzed, and if the fetus has Tay-Sachs, then the parents, not the doctor, the parents have the option of not seeing that fetus to term. So in other words, no one's killing any fetus, but it does mean that parents have a choice. And again, it's not a question of a doctor discriminating against the unborn fetus. It's a question that the parents are given the option of not seeing that fetus to fruition, to birth, because of the fact that that fetus carries the genes for Tay-Sachs. Now, in principle, this may make it possible to eliminate Tay-Sachs in that family tree within just one generation, if everything goes well. Now, what about the possibility of the misuse of this technology? Well, there are two ways in which genes might be altered. First is somatic gene therapy, in which you simply repair the genes of an individual that's already been born. But there's also germline gene therapy. That is, changing the genes that make up the sperm and the egg, and thereby being able to control your entire genetic destiny forever. Okay? Now, many of the people who work in this frontier area say that somatic gene therapy might be okay, because of course you don't want to perpetuate suffering. For example, Huntington's syndrome. Huntington's disease is a horrible disease where you flail about like a wild person. Woody Guthrie had the gene for Huntington's. In fact, it's even suspected that one of the so-called witches of the famous Salem witch trial actually suffered from Huntington's. And that, of course, probably upset a lot of the neighbors who thought that maybe she was possessed by the devil or was a witch herself. But some people think that no, perhaps she just had a genetic disease called Huntington's. And so why not eliminate Huntington's disease from one generation? That's somatic gene therapy. But on the other hand, more controversial is germline gene therapy, where you alter your sperm and the egg so that your kids and your kids' kids and your kids' kids on forever have that gene eliminated. So once again, it's not a question of the doctor discriminating against certain individuals. First of all, it's a frontier area. The law has not made clear exactly what is possible and what is not possible. But in the best case scenario, it's the parents who have the option. That is, they're given a choice as to whether or not they should perform, whether or not they should see a certain fetus to term or not. Okay, well, let's take a short commercial break. Once again, you are listening to Science Fantastic with Professor Michio Kaku. Give us a call. The hotline number is 866-323-2129. All we ask of you is that you leave your name, call letters to the radio station, and the city you're calling from, and perhaps you will share your thoughts on over 100 radio stations that carry Science Fantastic. So, give us a call.
You're listening to Science Fantastic with Professor Michio Kaku. You're listening to Science Fantastic.
Welcome back to Science Fantastic with Professor Michio Kaku. Once again, this hour is your hour. This means that you can always get to the phones and give us a call at 323-2129. Leave your name, call letters of the radio station, and the city you're calling from, and perhaps your thoughts will be heard on over 100 radio stations that carry Science Fantastic. So, once again, let's say that you're just shooting the breeze with some of your friends at work and something pops up. Something about science, something about the space program, something about UFOs or aliens, something about the latest breakthroughs in cancer research, and there's no one to talk to. Well, you can talk to me. You can give me a call at 866-323-2129 and make a comment or ask a question, and perhaps you can have your thoughts heard on national radio. And once again, go to my website. It's mkaku.org, mkaku.org. Or go to my Facebook site. We have 3 million fans on Facebook. Or Twitter. We have 500,000 people on my Twitter account. So find out what all the excitement is about by going to my website, mkaku.org, mkaku.org. Okay, well, moving right along, let's take the next listener phone call.
Hello, Professor Michio Kaku. My name is Mike McCrow in Beaverton, Oregon, listening to you on station 970 in Portland. I was wondering, ancient lava flows have shown that the Earth's magnetic field, because of the alignment of iron, has changed polarity from north to south several times in the history of the world, of the Earth. I was wondering, when this happens, what effect will that have on the Earth's magnetic field and its ability to prevent harm from the solar rays? Thank you.
Well, you ask a very thoughtful question, and you're absolutely right. If you go to, for example, Hawaii or any place where you've had multiple lava flows, and simply dig right into the lava flows, and calculate the direction of the magnetic field, which is very easy to do because you have iron crystals inside the lava, and when the lava freezes, the direction of the North Pole is frozen in the lava. And as the next lava flow comes, the Earth's magnetic field has changed, and you can actually see the direction of the magnetic field changing in direction as you dig deeper and deeper into the crust of the Earth. And then the question is, are we headed for another one? And the answer is yes. We have records going back hundreds of years of the strength of the magnetic field of the planet Earth. Not, of course, scientific, but enough that we scientists can thereby recreate the strength of the magnetic field going back centuries. And yes, indeed, we are due for another change because the North Pole, the magnetic North Pole, does tend to wander. Now, I have to, at this point, make a very strong statement. I'm talking about the magnetic north. I'm not talking about the geologic North Pole. What's the difference? Well, the magnetic North Pole can wobble. It can change because of the fact that there are different kinds of currents inside the Earth which give us the magnetic field. But the geologic North Pole wobbles only slightly. In fact, we think that's where the ice ages come from. Very tiny wobblings of the geologic North Pole affects the amount of sunlight we get over hundreds of thousands of years, and that influences the ice age. But they're different. So when I talk about a pole shift that is going to come in the next few hundred to 1,000 years, I'm not talking about a geologic pole shift, which would, of course, destroy much of life on the Earth. It would disrupt the oceans, the continents, set off earthquakes, and all sorts of stuff. If you saw some of the movies that Hollywood has created concerning Armageddon and Doomsday, you know what could happen if the geologic North Pole were to change. Now, the caller asked a different question, a more thoughtful question, and that is, what happens if the magnetic North Pole does continue to decrease in intensity and finally flip? Is it the end of the world? No. It's happened many times in the past. And after the break, we're going to talk about a planet that did have a magnetic field which was reduced to zero with catastrophic implications. That is the planet Mars. Okay, let's take a short commercial break. And after the break, we're going to continue with Open Mic on Science Fantastic. Give us a call. The hotline number is 866-323-2129 and have your thoughts heard on national radio. Give us a call because this is Science Fantastic with Professor Michio Kaku.
There may be an infinite number of universes, but there's only one correct answer. You're listening to Science Fantastic with Professor Michio Kaku. Michio Kaku.
Welcome back to Science Fantastic with Professor Michio Kaku. Once again, if you want to get on Science Fantastic and have your thoughts heard on national radio, give us a call. The hotline number is 866-323-2129. Well, before the break, we had a caller calling in, a rather thoughtful question, stating that, well, yes, the magnetic field of the Earth is gradually changing, and in the coming centuries to millennia, there could even be a pole shift. And is that dangerous for life on the Earth? Well, yes and no. First of all, we're not talking about a catastrophic shift of the geologic North Pole, which would, of course, split the Earth and create all sorts of havoc. We're talking about a change in the magnetic North Pole, which happens every few tens of or hundreds of thousands of years. It has happened multiple times in the past. Now, we need a magnetic field to protect us against solar flares and the radiation coming from the sun. Now, Mars has almost no magnetic field to speak of. Therefore, without a magnetic field to protect it against the sun's harmful rays, it means that Mars is continually bathed by radiation from solar flares. As a consequence, that's why Mars has almost no atmosphere to speak of. The atmospheric density is only 1% that of the planet Earth. So it means that if you were to take off your spacesuit on Mars, you'd suffocate, and the pressure being so low, eventually your face would actually explode as a consequence. So we, on the other hand, have an Earth with a very large magnetic field. That magnetic field sets up a shield that protects us from the harmful radiation from the sun. And that's why we have a very rich atmosphere on the planet Earth. Then the caller asked the question, well, if we do have another pole shift, which has happened in the past, what does it mean for life on the Earth? How dangerous it is? Well, it'll be dangerous because solar radiation will be bathing the Earth. But hey, look, it's happened before. We got through it. It may mean, for example, that life hundreds, thousands of years from now may have to go underground. We may have to temporarily live in underground shelters or cover ourselves to protect ourselves from the ultraviolet radiation from the sun, but it doesn't mean the end of the world. So no one's predicting the end of the world, even if we have a change in the magnetic North Pole of the planet Earth. It's happened before, and we got through it. And the strength of the magnetic field of the planet Earth is decreasing. We can actually measure that. We don't know when there may be a potential pole shift or a shift of the magnetic North Pole, but we are talking about something that will happen on a scale of centuries to millennia. In other words, don't hold your breath. Okay, well, let's move right on to the next listener phone call.
Hello, Professor. I was just wondering. I heard you're talking about the universe accelerating. My name is Nathan. I'm calling from West Virginia. And has anyone ever thought the universe is accelerating? Because at the far edges of the universe, the unknown area has mass. If it has mass, then it has gravity. Therefore, pulling the universe towards itself? Thank you.
Okay, well, I think what you're asking is, well, first of all, the universe is accelerating in its expansion. It's not slowing down like we originally thought. It's actually speeding up. And perhaps the reason for the speed up is, well, maybe there's a gigantic object way out there, an object that is so large that it is tugging on us, giving us the false impression that the expansion of the universe is accelerating, when actually it's only due to the presence of a nearby but very, very massive object. Well, that theory cannot be ruled out. However, it does not agree with the data today. In fact, let's take a short commercial break, and I'll talk about the data today, about exactly what is the large-scale structure of the universe. Once again, you are listening to Science Fantastic with Professor Michio Kaku. Give us a call. The hotline number is 866-323-2129. Ask a question, make a comment, leave your name, call letters of the radio station, and the city you're calling from, and perhaps you can be on over 100 radio stations that carry Science Fantastic. Give us a call.
You're listening to Science Fantastic with Professor Michio Kaku.
Welcome back to Science Fantastic with Professor Michio Kaku. Once again, the lines are open. This is Open Mic on Science Fantastic. This is when you can be part of the fun. I mean, why should we scientists have all the fun exploring the universe, exploring the genome, wondering what's out there, what does it all mean? Why should we have all the fun? Why don't you be part of the fun too? Why don't you give us a call at 866-323-2129 and you can have your thoughts heard on national radio. Well, before the break, we had a call. Yes, indeed, the universe is expanding. Everywhere we look, we see that not only are the galaxies moving away from us, but the farther they are, the faster they're moving. And we once thought that the acceleration was slowing down. Now we realize that it's actually speeding up. And that leaves us with the possibility that maybe one day we'll be headed for a big freeze. The universe will be so cold that even life itself cannot survive. All life will die when the universe itself freezes at absolute zero. Well, at this point, I advocate, and other scientists have discussed it, maybe we should leave the universe. Maybe we should leave the universe and create an interdimensional lifeboat and sail to another nearby universe where it's warmer, and perhaps we can mess up that universe as well as messing up this universe as well. Well, the caller asked a question. Is there a gigantic object out there that is tugging on us? Or that is the origin of this acceleration? And the answer we think is no, because everywhere we look, the universe seems to be uniform. In fact, it is uniform almost to a mathematical precision. When we measure the background radiation that fills up the universe, the remnant of the Big Bang itself, we find that it is remarkably uniform. So whatever explosion created a universe that is uniquely uniform. In other words, there is no large object out there tugging on us that we are aware of. However, the latest theory is called inflation, and inflation does leave the possibility that maybe the universe could be lumpier than we thought. Perhaps in our sector of the universe we had a cosmic explosion, but maybe, just maybe, Big Bangs happen all the time. Even as you're listening to this radio program, perhaps universes are being created. If that's true, it means like a balloon inflating, there are tiny sub-balloons that are peeling off and they are also inflating, and that creates a rather lumpy structure. But in all these balloons, in all these bubbles, the universe is still uniform within each bubble, and the universe is either accelerating or even contracting. That's called inflationary theory. It's gotten a lot of publicity. In fact, we had the originator of the inflationary theory, Professor Alan Guth of MIT, on Science Fantastic. He may eventually win the Nobel Prize in Physics for giving us perhaps the most accurate, realistic model of how the Big Bang took place, which in turn predicts there could be other Big Bangs happening all the time. Okay, well, moving right along, let's take the next listener phone call.
Yes, Professor Michio. My name is Ron, and I'm in Nikiski, Alaska. I'm just curious. I've watched a show on the History Channel about a guy who actually had a concrete building. He made his own little township. This guy defied gravity, but they didn't know exactly how he did it. He lifted blocks by using something natural that would weigh in the tons with no machinery, anything. And I just, curiosity-wise, what would be what you think of how this guy even accomplished that?
Okay, well, we'll have to take a short commercial break, but after the break, we're going to talk about anti-gravity. Can you really levitate? Once again, the number to call is 866-323-2129, and have your thoughts heard on national radio. So after the break, we're going to talk about anti-gravity.
You're listening to Science Fantastic with Professor Michio Kaku. Professor Michio Kaku.
Welcome back to Science Fantastic with Professor Michio Kaku. On Science Fantastic, it's open mic. And once again, I'm always on tour. Go to my website, mkaku.org, mkaku.org, and maybe I'll be signing your copy of my latest New York Times bestseller, The Future of the Mind. In fact, the book hit #1 on the New York Times bestseller, and it's now in paperback form. So find out what all the excitement is about. Well, where we last left off, we had a caller calling in about something that's quite exotic, but it's a question that I often get, and that is, what about anti-gravity? Throughout history, there have been a number of reports, some of them rather convincing, that seem to indicate that people can literally defy gravity. Think of it, people that climb ropes, Jack and the Beanstalk-like, and go to heaven simply by levitating. In fact, the transcendentalists even have a photograph of some of their people meditating, and there they are hovering above the floor. Unfortunately, when people ask to have a demonstration of this in a scientific laboratory, they have demurred. But let me say a few things about what science says about anti-gravity. First of all, the science as we know it, that is quantum physics and relativity, which are the two leading theories of the universe, they do not allow anti-gravity. I repeat, NO. So it means that all the tricks that you've seen in magic shows and stuff like that are exactly that, tricks. However, when you go to the very edges of science now, then you're talking about, well, there are caveats, there are footnotes that you have to add to Newton's laws of gravity, Einstein's laws, and the quantum theory. First of all, if there's something called negative matter, that is the opposite of matter, not antimatter, but negative matter would fall up. It would have anti-gravitational properties, but we see no evidence of it. In fact, if there was negative matter on the Earth billions of years ago, it would have literally floated away. Now, why are we physicists interested in negative matter? Because if you have enough negative matter, you can violate so many laws of Einstein that you could have a time machine. That's right, a wormhole machine, a time machine, warp drive, all the stuff you see in Star Trek would be possible if we had large quantities of negative matter. Now, to be frank, we see no evidence, I repeat, no evidence whatsoever of negative matter. All I'm saying is that if negative matter did exist, it would break Einstein's laws in a very precise way, such that things would float, things would fall up, not down, that you could get levitation. And if you have enough of it, it would actually warp Einstein's equations so much that it would allow for time travel and warp drive and pretty much everything you see on Star Trek. There's also yet another way of creating anti-gravity, and that is the fact that the universe seems to be accelerating. In fact, the Nobel Prize was given to 3 astronomers a few years ago for this astounding discovery that the universe is not slowing down in its expansion, it's actually accelerating, careening out of control. This means that something is pushing the galaxies apart, and we think that it is dark energy, the energy of nothing. Even nothingness has energy as predicted by Einstein's equations. And perhaps that's the reason why we have an accelerating universe. Well, that creates anti-gravity, because anti-gravity is pushing the galaxies apart. However, to be fair, I have to say that the amount of anti-gravity pushing the galaxies apart is minuscule, tiny. So small, you cannot build a time machine out of it. So small that it's of no practical use whatsoever. We do know that between galaxies, however, there's enough of it so that you can, in fact, push the galaxies apart. So that is a form of anti-gravity that we think can exist, but it is extremely tiny. You're not going to be able to levitate off the floor using this kind of technology. So anyway, just to repeat, anti-gravity as seen in science fiction movies is not possible using the known laws of Newton, Einstein, and the quantum theory. However, there are fuzzy areas. If you have negative matter, which we've never seen before, then perhaps anti-gravity is possible. But, well, don't hold your breath. We have yet to find any evidence whatsoever of negative matter. Okay, well, I think there's time maybe for one more listener phone call. Let's take the next listener phone call.
Hello, my name is Verl Potter. I live in Richland, Washington. I listen to you every Sunday night from 8 to 10 p.m. on radio station KONA. It's Kona, which is 610 on the radio. My question is, I heard that all the planets rotate counterclockwise, including Earth, except one, Venus. Someone told me that Venus is the only planet that rotates. All the planets rotate counterclockwise. And I was told that Venus is the only planet that rotates clockwise. Why is that? I was just curious. Thank you. Okay, bye now.
Well, you're absolutely right. Venus is an oddball. But first of all, let's describe the solar system itself. We have the sun, of course, at the center, and then we have a disk called the ecliptic plane, a disk that surrounds the sun, and all the planets lie along this disk. Now, inside this disk, all the planets go around the sun in the same direction. I repeat, all the planets go around the sun in the same direction. However, inside each planet, they have their own spin. And if you take a look at the spin of the planet, we find that Venus actually spins in the opposite direction. So in other words, all the planets move in the same direction around the sun in this disk called the ecliptic plane. But inside the ecliptic plane, each planet spins on its own axis. And if you take a look at the Earth, Mars, and Mercury, we find that its spin is in the same direction, but Venus goes backwards. And why is that? We think there probably was a cosmic collision when the solar system itself was first formed 4.5 billion years ago, and these cosmic collisions created the bizarre shape of the solar system. Where did our moon come from? From a cosmic collision with an asteroid about the size of Mars. But in the form of Venus, we think that a collision took place which reversed the spin of Venus. Well, unfortunately, that's it for Science Fantastic.
You're listening to Science Fantastic with Professor Michio Kaku. Black holes, the cosmos, space, and time travel, medicine, robotics, science, and technology. Professor Michio Kaku, theoretical physicist, graduated from Harvard University summa cum laude and first in his physics class. Received his PhD in physics from the University of California at Berkeley. And now, a professor of physics at City University of New York for 30 years. His goal? To complete Einstein's dream of a theory of everything, to derive an equation, to summarize all the physical laws of the universe. The co-founder of string field theory, author of the international bestsellers Hyperspace, Visions, and Parallel Worlds, and voted as one of the 100 smartest people in New York, profiling the latest cutting-edge developments in science, which revolutionize our world and touch our lives. Now, Science Fantastic with Professor Michio Kaku.
This is Science Fantastic with Professor Michio Kaku. On Science Fantastic, we profile the amazing, jaw-dropping scientific discoveries which are revolutionizing our world and touching our lives. And once again, in this hour, it's open mic. That's right, open mic. This hour is your hour. This is the time when you can get to the telephones and give us a call at 866-323-2129. Let's say you're having dinner with the kids, and all of a sudden they ask you a homework question that leaves you stumped. Well, you don't want to be a dummy in front of your kids, so why not give us a call at 866-323-2129 and ask that question. Or, for that matter, maybe you want to put your kids on the radio and have them ask that question personally. So once again, the number to call is 866-323-2129. All you have to do, by the way, is leave the call letters of the radio station you're calling from, your name, and your city. And perhaps you can get on over 100 radio stations that carry Science Fantastic. So once again, give us a call at 866-323-2129. And we should also say that you can go to my website. My website is mkaku.org, mkaku.org. It shows you how you can get on Science Fantastic and also get a copy of my latest book, The Future of the Mind, now in paperback form. You know, when you listen to the advertisements for the Hollywood movies, they talk about telepathy, they talk about robotic arms and legs, Iron Man costumes, recording memories, none of which is possible today except in the laboratory. In the laboratory, we have created Iron Man costumes that actually could give superpowers to people who are crippled and paralyzed. Telepathy, we can actually send thoughts on the internet. Recording memories, the first simple memories have actually been recorded. All of this has now been made available because of advanced physics. So find out about what's available by getting a copy of my book, The Future of the Mind. I should also point out that this is for real, and one of the main backers of this technology is the United States Pentagon, because they want to make sure that our wounded warriors from Iraq and Afghanistan get the best medical care and have the ability to perhaps bypass the spinal cord, which is injured, so that these people can start to have a semi-normal life once again. So once again, the book is called The Future of the Mind, now in paperback form. Okay, once again, the lines are open. Give us a call at 866-323-2129. Let's move on to the first listener phone call.
Hello, Professor. My name is Tim. I'm calling out of Chattanooga, Tennessee, WTOW 1150 FM. I'm sorry, AM. My question is, when a person gets amnesia, how is it that they're able to remember how to, read, write, speak, recognize things around them, but they can't remember the higher functioning things such as their name, where they're from, and certain other things? Thank you.
Well, there are a lot of things we don't know about the mind and amnesia. However, we do know that different parts of the brain store different memories. So stroke victims, for example, that have damage to one part of the brain means that memories stored in that area are corrupted, but other parts of the brain function perfectly well. Also, short-term memories are processed in what is called the amygdala, the hippocampus, which is located dead center in the human brain. The hippocampus takes sensations and records them as memories and then stores them. So if you have an injury to the hippocampus, for example, Alzheimer's disease will injure and, in fact, destroy the hippocampus, it means that your ability to remember short-term memories begins to fade, but long-term memories are intact. In fact, with people in Alzheimer's, in mid-stage Alzheimer's, people begin to forget where they put their keys, they forget who they're talking to, they forget short-term memories, but long-term memories, that is, learning how to ride a bicycle, playing the piano, knowing the names of your children, long-term memories are intact. And in fact, there was once an injury that took place in an operation to a man named Mr. M, and he lost the ability to form short-term memories. In other words, he would say hi to you when he met you, and a few minutes later, forget who you are, forget that he even said hi to you, and he says hi to you all over again, repeating himself over and over again. This went on for decades because he had permanent injury to the hippocampus. His story is so incredible that several Hollywood movies have been based upon Mr. Maliason's ailment. For example, the movie with Drew Barrymore, 50 First Dates, where a woman constantly forgets the date that she just had, and poor Adam Sandler has to court Drew Barrymore 50 times because she forgets everything. Also Groundhog Day with Bill Murray. So these are movies based on real amnesia caused by brain damage. Also, long-term memories are stored on the surface of the brain in different places. For example, apples and oranges, vegetables, animals, they're stored literally in different parts of the surface of the human brain. So injury to one part of the brain will affect memories stored in that part of the brain, but not affect memories in other parts of the brain. Well, to find out more about amnesia and all the different kinds of ailments that we suffer from, and how scientists are beginning to decipher how these mechanisms interfere with our thinking, get a copy of my latest book, The Future of the Mind. Okay, well, let's move on to the next listener phone call.
My question is, what are the symptoms of this new Zika virus that's going around? Nobody's telling what the symptoms are. Anyway, thank you.
Well, yes, the Zika virus is causing a tremendous amount of anxiety, especially among pregnant women or women who are thinking of getting pregnant, because the virus, we think, is spread by mosquitoes, and we know very little about it. So how is it that things like Ebola virus and the Zika virus simply jump out at us, creating huge headlines? Where did they come from anyway? Well, the source of most of the illnesses that afflict the human race come from animals, and they cross over. And many times these animals live in certain pockets, and they live undisturbed by humans. Every once in a while, a human comes across them, perhaps eats the animal, and becomes infected. But it's very rare, because these are isolated settlements. Now, of course, we have jet travel. We have developments where we basically tear down entire areas of land to build housing tracts. And because of this, we are encroaching upon their habitat. These diseases and these animals have probably lived in peace for millions of years until humans begin to interfere and move into their ecosystem. And that's why, as humans expand into more and more environments, you're going to see more and more exotic diseases. Some of these exotic diseases are perhaps even older than humanity itself. very old diseases that were left untouched for millions of years until humans began to trample upon their domain. Now, the Zika virus, the symptoms are very mild, and that is very frustrating because many people have been infected by the Zika virus and don't even know it. However, it does create, we think, microencephaly, which causes a very severe form of mental retardation. In fact, if you take a look at the genes of that, you find out that the genes of microencephaly are very similar to the genes of our ancestors millions of years ago. So one of the reasons why our ancestors had small brains is precisely because they had a gene for brains that were not very large. Of course, in the millions of years, that gene mutated in our brain, allowing our brain to grow explosively. But we're still learning about it. So I would advise you to go on the web, Google the Zika virus, and find out the fact that we're constantly learning more things about the virus because, well, it jumped out at us. And right now we have no vaccine. It's, at the present time, incurable. Okay, well, let's take a short commercial break, and then we'll continue with Open Mic on Science Fantastic. Write this number down, 866-323-2129. And when you hear the recording, give us your name, the call letters of the radio station you're calling from, and the city you're calling from, and ask your question, make a comment, and perhaps you can be heard on over 100 radio stations that carry Science Fantastic. So give us a call. No question is too dumb or too silly to put on national radio. Some of the dumbest questions are the most profound questions of all. So give us a call at 866-323-2129.
This is Science Fantastic. Most up-to-date announcements and analysis from today's technological leaders every week on Science Fantastic.
Welcome back to Science Fantastic with Professor Michio Kaku. On Science Fantastic, we profile some of the most amazing developments in science. And in this hour, we're throwing the lines open, and you can be part of the fun. Give us a call at 866-323-2129. Ask your question or make a comment and have your thoughts heard on national radio. That's right. Just give us your name, the call letters of the radio station you're calling from, the city you're calling from, and perhaps you can have your thoughts heard on over 100 radio stations that carry Science Fantastic. Okay, well, moving right along, let's move on to the next listener phone call.
Hello. What is the biggest scientific truth that has been changed in the past 10, 20, and 50 years? And to make sure you understand, 50 years ago, science said this is the absolute truth as we know it. But now, with all the information that we've gathered in the past 50 years, we know it to be nowhere close to the truth. So what is the biggest truths that are no longer the truths in science? Thank you.
Well, you ask an embarrassing question, but science, of course, is constantly updating things because, of course, we're getting closer and closer to the way things really are. Well, one embarrassing thing that happened recently is the fact that we've been teaching something that now we know to be incorrect. High school kids believe that the universe is mainly made out of atoms. We've been drilling this into kids for many a decade, starting with hydrogen, helium, going all the way up to uranium. We say, well, that's it. You know, atoms and their subatomic particles. Atoms, that's what the universe is made of. Well, boy, were we wrong. We now realize that atoms only represent a small fraction of everything there really is. First of all, the atoms of hydrogen and helium that make up the sun, they in turn only make up 4%. 4% of the universe. We, that is the higher elements like oxygen and hydrogen, oxygen, carbon, and nitrogen, the higher elements only make up 0.03% of the universe. So we are the oddballs. We're the exception to the rule. However, what about the other 96%? We know that 23% of the universe is made out of dark matter. Boy, were we surprised when this became accepted scientific truth. Dark matter is invisible. It surrounds the Milky Way galaxy, holds the galaxy together, but because it is invisible, it is extremely hard to analyze. We know it's there. We have maps of dark matter taken by the Hubble Space Telescope because light bends as it goes through dark matter, but we don't know what dark matter is. There's a whole shelf full of Nobel Prizes waiting for people who can actually tell us what dark matter is. And then to make it worse, there's dark energy. Dark energy makes up the rest of the universe. So we're talking about over 70% of the universe being made out of dark energy. Dark energy has anti-gravitational properties, so it pushes the galaxies apart. People wonder, why is the universe expanding? What's pushing the galaxies apart? The answer is dark energy, and we're clueless as to what dark energy is. Well, we do have theories, quantum mechanics, for example, allowing us to make a first guess as to what dark energy is. The first guess that we make is off by the biggest number ever recorded in the history of science, 10 to the 120. Take a sheet of paper, write the number 1, and then put 120 zeros after that 1. That is a number so big that we don't even have a word for it, but it is the mismatch between what quantum mechanics predicts and the actual value of dark energy in the universe. That is embarrassing. I mean, the biggest number ever seen in science tells us how off and how incorrect our theories are. In fact, if you can find out what dark energy and dark matter are, well, give me a call first, and we can share the Nobel Prize. So I think that ranks up there as one of the greatest embarrassments, that the truth of 50 years ago is no longer a truth at all, that atoms are a minority. Most of the universe is made out of dark matter and dark energy, and we are clueless to explain them. I should also point out that string theory, which is what I do for a living, string theory does predict that dark matter is the next vibration of the string. This has not yet been proven. String theory says that we, that is, the atoms that make up our body, we are made out of the lowest octave of the string, but the string has many octaves. The next higher octave should give us dark matter. But like I said, hey, your guess is as good as mine. Okay, well, moving right along, let's take the next listener phone call.
This is Dan in Healy, Alaska, and I've been up here about 33 years, and this is connected with the earthquake that caused the tsunami in Japan. And we have noticed since then, and when I say we, I'm talking about the entire community, that the sun is coming over the mountains earlier and much higher in the beginning of the year as it had done before the tsunami. Can you comment on that, please?
Well, the tsunami that caused the death of about 10,000 Japanese citizens was set off by a magnitude 9 earthquake, one of the largest ever recorded in the history of science. It was a whopper, a gigantic earthquake which set off a tidal wave which then engulfed the whole area in northern Japan, killing about 10,000 people. But then the next question is, well, what about the long-term effects? Did it actually shift the rotation of the Earth? And the answer is, yes. However, it is a very, very tiny amount. We're talking perhaps a millionth of a second over many, many months. And so, in other words, you're not going to even notice it. you're not going to even notice the fact that the day is a little bit different than it was before the Fukushima disaster. Now, you can actually calculate this number. We know basically the mathematics of rotating systems. The Earth compressed a little bit, and we know how much dirt was compressed, roughly speaking, because we know how big the fault line is. And you put the numbers in, and bingo, you calculate that the day is not quite what it used to be, but it is so small, it is unmeasurable. Same thing with the axis of the Earth. It too shifted, but hey, not by much. Okay, let's take a short commercial break. Once again, you are listening to Science Fantastic with Professor Michio Kaku. Keep the calls coming. The hotline number is 866-323-2129. Give us a call. Leave us your name, the call letters of the radio station, and the city you're calling from. And perhaps you can have your thoughts heard on over 100 radio stations that carry Science Fantastic.
Back off, man. I'm a scientist.
Science Fantastic with Professor Michio Kaku.
Welcome back to Science Fantastic with Professor Michio Kaku. On Science Fantastic, we profile some of the most incredible developments in science, and you can be part of the fun. You can be part of the dialogue by giving us a call at 866-323-2129, and perhaps I'll be signing your copy of my latest book. I'm always traveling. Go to my website, mkaku.org, mkaku.org. Find out where I'm going to be traveling, and perhaps I'll personally sign your copy of The Future of the Mind or The Physics of the Impossible. I've written 3 New York Times bestsellers, including Physics of the Impossible, and perhaps I'll be signing your copy. And then, of course, you can go to eBay and auction them off for money. Autographed books actually are worth money. So you can actually make money by coming to my book tour. Okay, well, moving right along, let's take the next listener phone call.
Hello. I would like to know what would happen if any of the lower Great Lakes overflowed their banks. How much flooding would ensue and how quickly? Thank you.
Well, the answer to that question, of course, depends upon how the overflow took place and how much water overflowed. However, we can get an inkling as to what might have happened by running the videotape backwards. If you were to go back 10, 20,000 years, you would be at the tail end of the last ice age. And as the ice began to recede, it created lots of water, which in turn causes flooding, and created lakes. So as the ice began to melt and contract, it left large puddles of water. For example, Salt Lake, the Great Salt Lake is one of these large bodies of water left over from the Ice Age, and the Great Lakes. The Great Lakes themselves are the remnant of the ancient glacier that was once sitting on top of North America. The height of the glacier was up to half a mile. It was huge. So you can imagine the amount of flooding that took place as the ice began to melt. And then running the videotape forwards, you can now get an inkling as to what would happen if the Great Lakes were to overflow once again. So in other words, it actually happened in reverse. As the ice began to melt, water began to flood into all sorts of nooks and crannies and create large bodies of water like the Great Lakes. And by running the videotape backwards, we can get a feeling as to how big and how much flooding took place during that period of time. So again, the amount of flooding, the amount of damage that it would do, all depends upon the circumstances and the amount of water that is being moved. However, we do know that it happened in the past. that in the past there was water, tremendous amount of water. They caused flooding. They caused the banks to overflow, and that is a byproduct of the last ice age. Also, if you look in New York State, for example, you can see lakes that look like fingernail scratches. It looks like a giant from outer space reached down and scraped the surface of the earth with his fingernails, leaving gouge marks with the shape of parallel lines. Finger Lakes was responsible for causing this effect. And so we think that that is yet another indication of the massive ice age that existed 10,000 years ago. Okay, well, moving right along, let's take the next listener phone call.
Yes, I believe in flying saucers and alien technology. My question is, from 1950, right after Roswell incident, to the year 2016 is 66 years. How did man become so smart in technology in less than 100 years and was so stupid in technology in the past? Thank you.
Well, you ask an interesting question that I often get. In fact, many people make the logical conclusion, therefore, that alien technology is what made the difference. People are saying we should reverse engineer the technology that the aliens have given us, and that's what we've been doing for the last 50 years. Where did the transistor, where did the GPS, where did all the lasers, and where did the internet come from? It came from alien technology. Well, I have a slightly different point of view on this in the sense that I'm a physicist, and I know some of the people who were there helping to create many of the wonders of the modern age. Take a look at the laser. The laser was invented by Charlie Towns, a physicist who won the Nobel Prize, and he was more or less the physicist down the corner from my office. I had an office in Burge Hall at the University of California at Berkeley years ago. Down the hall was Charlie Towns, the inventor of the laser. And if you look at his work, you can see all the dead ends, you can see all the mistakes and all the tears and frustrations he had before he finally struck gold and invented the laser. Same thing with the transistor. The transistor, which makes the computer possible, which in turn is the backbone of this technological revolution, was created by 3 physicists. And these physicists worked at Bell Labs. So did Charlie Towns. And again, you can see the history of the frustrations, the dead ends, the tears that had to be shed before they made their fundamental breakthrough, creating the transistor. The point I'm raising is that if you're a physicist, you know the steps. You can complete the dots. You know all the missing steps where, painfully, we began to create the computer. We began to create the internet, the GPS system. So in other words, we don't need aliens from outer space. We don't have to reverse alien technology. It's homegrown scientists that did it. But unfortunately, we scientists don't have access to the media. Movie stars do. We don't. So when we announce that we've created something called the computer, it shocks people. The computer must have been invented by aliens. No, it was invented over a period of time by scientists working painfully day by day to make their dreams come true. So in other words, maybe aliens exist, maybe not. Flying saucers exist? I don't know. Maybe, maybe not. All I'm saying is we don't need flying saucers to explain the technological marvels that we see all around us. So let's take a short commercial break. Once again, the number to call is 866-323-2129. Leave your name, call letters at the radio station, and the city you're calling from, and perhaps your thoughts will be heard on national radio. So give us a call.
This is Science Fantastic. Fantastic.
Welcome back to Science Fantastic with Professor Michio Kaku. The lines are open. That's right. You can get right to us without getting a busy signal 24 hours. 24 hours, day or night. You can have your thoughts heard on national radio by giving us a call. The number is 866-323-2129. When you hear the recording, leave your name, leave the call letters of your radio station, and also leave what city you're calling from. And perhaps your thoughts will be heard on national radio. So give us a call. Okay, well, moving right along, let's take the next listener phone call.
Yes, my question has to do with antiparticles. Basically, do antiparticles fall up or they fall down? I don't think anybody knows. If they, in fact, fall up, then it may answer the question about black energy, dark energy, I'm sorry. We wondered where it all went at the formation of the Big Bang. It may be out there in what is causing the ever-accelerating expansion of the universe. Thank you.
Well, you ask a very profound question. And yes, you're absolutely right. We physicists don't know whether antimatter falls up or down. So let's back up a few steps. First of all, antimatter does exist. You don't have to watch Star Trek to get a handle on the antimatter. Just Google it, and you'll realize that we can create beams of antimatter. For example, atom smashers in the United States and Europe can create beams of antimatter that can then slam and collide with beams of ordinary matter, releasing large amounts of energy in the process. So antimatter exists. It has the opposite charge of matter, so the electron, instead of being negatively charged, the anti-electron is positively charged. But then the question, does it fall up or down? And the answer is we don't know. However, we think it falls down. In fact, most of quantum mechanics says that antimatter must fall down. We've never done the experiment because, of course, it's very difficult to do. These are absolutely small particles, and measuring them falling down is very difficult. Well, let's take a short commercial break, but after the break, we're going to continue a discussion of antimatter and why do things fall down rather than up. Okay, give us a call. The hotline number is 866-323-2129. So be part of the fun. Give us a call. Ask that question. Make that comment that you've always wanted to make and have your thoughts heard on national radio by calling 866-323-2129. Give us a call.
This is Science Fantastic.
Welcome back to Science Fantastic with Professor Michio Kaku. It's open mic in this hour. So once again, this is your chance to have your thoughts heard and your questions answered on call us 24/7, anytime, day or night, at 4 o'clock in the morning. In fact, you can call 866-323-2129. Leave your name, the call letters of the radio station you're calling from, and the city you're calling from, and perhaps you could have your thoughts heard on over 100 radio stations that carry Science Fantastic. Okay, well, lines are lighting up, so let's take the next listener's phone call.
Yes, sir. It's an honor to speak to you. I would like to know how long it takes for the ocean current to go from Fukushima, Japan, to the Kenai Peninsula in Alaska, and do our Alaskan salmon swim through those contaminants, and would you chance eating them? Thank you, sir.
Well, you ask a question that a lot of people asked after that Fukushima accident a few years ago, realizing that large amounts of radiation did in fact come out of that reactor. In fact, it was second only to Chernobyl. Chernobyl actually released more radiation into the atmosphere, and we know that it definitely had a very bad effect on the area. For example, cancer. Thyroid cancer in children went up as a consequence if you take a look at the distribution of radioactive fission products that came out of Chernobyl. Now, Fukushima is a little bit different in the sense that it's near the ocean. And yes, radiation did get into the ocean. You can measure it. Yes, some of it went into the fish. But as the industry likes to say, the solution to pollution is dilution. In other words, at Chernobyl, we did not have that much diffusion and dispersion of the radioactive materials. For example, it rained. It rained after the Fukushima disaster. Many of these fission products are water-soluble, and a lot of the radioactive iodine and other chemicals washed into the ground, getting into the food chain. Now, Fukushima things are different in the sense that most of the radiation blew into the ocean, and radiation then went into the ocean itself, which then has ocean currents, which diluted the radiation. You can measure it. The amount of radiation is measured in something called picocuries per liter, and it is infinitesimally small, thank goodness, because of the dilution effect. But as the caller mentioned, some of it went to Alaska. In fact, by satellites, you can actually see some of the debris that came out of the accident at Chernobyl, basically people's homes and household materials, papers, toys, books. And it created a gigantic sea of debris that washed up as far as California. So people in California could actually pick up on their beach things that were left over from debris that was left over from the Fukushima disaster. Did it go to Alaska? The answer is yes. How long did it take? Just a few weeks. The ocean currents traveling at a very mild, 5 miles per hour, can definitely go from Japan all the way to Alaska. But is it a health concern? And the answer is, as far as we can tell today, the answer is no. We can measure the radiation. The radiation is small, it's there, measurable, but it's not at the point where we have to issue alerts. However, the real alert is that people should be mindful that when a nuclear power plant is built in their backyard, they have to realize that, hey, with the tax breaks, with the coming of jobs, with the building of a nuclear power plant, you also have the possibility that it could go berserk, in which case your property values would definitely be affected. Okay, well, moving on, let's take the next listener phone call.
Hi, this is Matthew calling from Tumon, Guam. I have a question about gravity and planetary exploration. This is going to Mars and astronauts. We have a mission to go to Mars, and so on Mars, the gravity of Mars is supposed to be 1/3 of the Earth. How will we solve the problem of the lower gravity and its effect on humans' colonization in Mars to equal it to where it's at a balanced gravity, so we don't have the negative effects of less gravity? Are there ways of working on this in science? And does the sun have a gravity? What's the estimated gravitational weight or measurement of the sun?
Okay, well, you ask an embarrassing question in the sense that as scientists call for a manned mission to Mars, we have to realize that there are problems. For example, not just weightlessness in outer space, but also the fact that Mars is smaller than the Earth, and therefore the gravitational pull is going to be smaller than what we see at the Earth, and astronauts would have to adjust to that differential. Now, in outer space, there is a way to cure this problem, and that is spin the spacecraft. The centrifugal force of spinning is sufficient to create an artificial gravity. In fact, if you saw the movie 2001, there was a great scene where on this spaceship to Jupiter, you could literally run around the entire spacecraft upside down because you are in a rotating ring. But can you do that on Mars? And the answer is no. Some of the problems of weightlessness will also be problems on Mars. That is, loss of muscle tone, loss of calcium, phosphorus, many of the basic elements of life, headaches, all sorts of things that we get in weightlessness will also be found on Mars, because there's really not much we can do to the fact that Mars has a lower gravitational field, while the Sun has a much higher gravitational field because its mass is so great compared to the mass of the Earth. Well, unfortunately, that's it for Science Fantastic. Once again, you can be part of the dialogue. You can be part of the fun by giving us a call at 866-323-2129. 24 hours, day and night, you can give us a call. leave us your name, the call letters of the radio station, and the city you're calling from, and you can get on national radio. So be part of the fun. Give us a call, ask that question, make that comment, and have your thoughts heard on national radio on Science Fantastic.
The most up-to-date announcements and analysis from today's technological leaders every week on Science Fantastic.